Hello, everyone. Thank you for coming to the Lightning Talks, My Career in Languages and Compilers. We'd encourage everyone to ask questions in the Q&A chat box on the bottom, but we will be saving the questions for the end. I'd like to start off with Kaya.
Hello, everyone. Really glad to be here with you all and share a bit about my career journey. I'm currently a senior software engineer at Calm, which is a meditation and relaxation app, and the founder and creator of We Read Too, which is a mobile app that serves as a directory of children and young adult books written by authors of color. But before I get into my career, I really wanted to take you along the journey of how I got here. So growing up, I really always loved science and math, but I didn't know anything about computer science or software engineering or coding. I actually took a career aptitude test when I was in the 7th grade that said that I should become an engineer. And so when I went home to my parents and told them, they said that was great. I could be a mechanical engineer. I come from New York, and my stepdad worked in the MTA. And so when he heard engineer, he thought about construction engineers. So that was really my main idea of engineering. And so when I went to Dartmouth as a college student, I actually had declared an environmental engineering major. And I was really into sustainability. And I thought, going into environmental engineering, I would be able to work in the sustainability space. But as I started to kind of plan out my whole college experience and classes, I realized that I wouldn't actually get to the engineering courses until maybe my junior year. And my first 2 years were going to be filled with prerequisites of biology, physics, chemistry, a lot of courses in which I had already taken in high school. To kind of rethink, and I was wondering if maybe I didn't want to be an engineering major anymore. And it was after my first term. I was a first-year student, and I was home for winter break. And I came across a TED Talk by Kimberly Bryant, the founder of Black Girls Code. And she gave this TED Talk in 2013. And in the talk, she was talking about how computer science and software engineering is an expanding field. And we need more women of color studying computer science so that they can become software engineers in the technology industry, and how important it was to diversify the technology industry. And before then, I really just wasn't really aware of what software engineering was or computer science. So after watching that TED Talk, I signed up for my first coding course on Codecademy. And so I learned Python, and I fell in love with programming and the idea of programming languages. It was just fascinating to get that first hello world and realize that you could, write code and have that code turn into something real that someone can maybe interact with or play around with. And so I signed up for my first course called Programming Through Interactive Art. And that was my first computer science course that I took at college. And in that course, we were using JavaScript to create Java applets, where you could create games, where you could use kind of music and kind of change audio and create music with code. And I was just so enthralled. I would create these applets and then take them to my friends and ask them to play around with them. And to me, I just felt that coding and programming was just this immensely creative thing. I've always loved creative endeavors, drawing, theater, and growing up, I was always involved in different creative performing arts, and I enjoyed writing and reading. And so to me, coding felt like the perfect meld of my kind of science and math interest, and then the creative side of me that I always liked to really cultivate. And so with coding, I felt that I could, with the process of coding and creating a system, I could then create something that's creative that someone could actually interact with and use. And so after my first course, I knew that I was going to be a computer science major. And I started looking up, okay, how does someone make a career in software engineering? And so I created a GitHub account, right? And I created my first website using GitHub Pages and created a stack And then I got my first job on campus as a student programmer in a game design lab. And we were creating games for social change. And in that lab, I was able to really take what I was learning in my coursework, but make it real and make actual real websites and applications that folks were using and that were having impact. One of the things I remember most from that experience is I created a game that was helping the Britannica Library basically tag metadata. And they did it where they would have an image show up and you would have to kind of think like Pictionary, put in different words and whatnot. And they were using those words to then be able to tag the different content to have metadata on the internet. And so that was a really great first experience. It wasn't until my first internship that I discovered iOS and mobile development and programming. And so I was going to do an internship at Time Inc. in New York City. And my manager asked if I knew iOS. And at the time I didn't, but I knew that I would be able to learn. And so I started out doing my first internship in iOS. And I realized that with the skills I was learning in my internship, I could create an app. And that's really when I began to create We Read Too. And this was in 2014. And the idea around We Read Too really stemmed from my own love of reading and realizing that a lot of the most popular books and things that were being out there were not as diverse. And I didn't really find myself in a lot of the books I was being exposed to. And so I wanted to create a resource where folks could easily find diverse books for kids and teens. And so that's why I created We Read Too. And for my career, after I created We Read Too, I really just went full force into iOS and specifically Swift, of course, which came out around the same year that I launched the first version. And so as my career, also the Swift language has developed, and it's been amazing to be able to see the language grow and the community, the open source community grow as my own career in software development has grown as well. And now since that first internship, I also interned at Intuit and then Apple. And after I graduated college, I started working at Slack for a few years, and now I'm at Calm. And being at Calm for the last 2 years has been an incredible experience to be able to take those coding skills and again, be able to make something that people can interact with, but also that's having a positive impact on folks' lives. So working on a wellness software has been really, really great. And I think for me as a software engineer, and I think the beauty of programming languages is to be able to create something that can really positively benefit folks' lives. And I've been really honored that I've been able to create that type of software and put those type of things out into the world. And thank you so much. I'll bring on Cindy. I really appreciate being here and glad to share my story with you all.
Thank you, Kaya, for sharing your experiences. Next up, we have Jessica.
All right. Hi, everyone. I'm Jessica. So today I wanted to talk a bit about how I ended up working in compilers in the first place. So I think that a lot of people think that you need a certain kind of background to end up working in compilers, in my case, working on LLVM, and hopefully I can disprove some of that. So first off, let's talk about background. So I've heard some career progressions that start out with, well, both my parents are engineers and I wrote my first basic interpreter when I was like 5. If this is your progression, that's awesome, but that is not my progression at all. I'm from a very small town on Vancouver Island in Canada. It does not have Vancouver on it. It's a different place. Neither of my parents actually finished high school, and I didn't meet an engineer until I was about 17 years old. I had some interest in computers, but what I really, really loved was actually art. I figured that I'd work on video game art or storyboarding or something. except, well, financially, I wasn't really in any position to chase after something that wasn't guaranteed to pay off a student loan. And so that means that art was out. In 11th grade, I took an IT class. And during that class, I found out that I actually really like programming. I'd done a little programming in the past, mostly web front-end stuff and messing around with this program called Game Maker. What I found was writing little command line tools was really, really satisfying. My tech teacher had an electrical engineering degree. He'd worked as a software engineer in the past, and he was the first engineer that I had ever met. I hadn't really known that engineer was something you could do with like computers. Everyone at my school thought that engineer meant someone that makes cars. So when I found out what a software engineer was, it sounded really interesting. You could make really good money, and you could also have a lot of fun making that really good money. So that seemed pretty ideal to me. Another teacher suggested two schools for computer science. One was the University of Waterloo in Ontario, which was on the other side of the country, and the other was the University of Victoria, which was only a few hours south of me. I could only afford to apply for one school, so I decided to try for UVic and apply for a student loan. I got in, and I think I was actually the only person in my tiny graduating class that went into computer science. During my time at UVic, I found out that I really like graph theory and algorithms. I mostly found that out because people would always say, algorithms are hard and graph theory is hard. And in my experience, a lot of the things worth doing are hard. And so I ended up focusing my degree in those topics. Now, a little bit later in my degree, I heard compilers are hard. And to be good at compilers, you have to know all the theory stuff, and you have to know all the hardware stuff. My university offered a compiler construction course, and so I went for it. Our course used LLVM, so I got a little bit of exposure to it there. But near the end of my degree, I was still mostly interested in theory. But I also didn't have a lot of programming experience outside of classwork, and I realized, oh my God, I really need to get better at this. So I decided to take the summer off and focus on side projects. Ultimately, I ended up getting an internship at a local company that was making an app that would help veterinary students study animal anatomy. So how does this turn into a career for compilers? Well, one day during my summer internship, I saw a tweet by somebody that I looked up to as a programmer. And she mentioned that her boss wanted to hire more women. It was basically, hey, if you're a woman and you're interested in compilers, then send me a DM. And I figured, well, what's the worst thing that could happen? Well, somebody says no. And what's the best thing that could happen? Well, I get an awesome job and compilers are cool. The only risk in that situation is a slightly bruised ego, and the potential reward was having my life changed. So I sent a DM. And then I got an email from an apple.com email address, and my heart nearly stopped, and I was like, oh no, what am I doing? Everything went really quickly after that. I bombed the interview. My ego was, well, slightly bruised. But I got over it. I decided to go back to the drawing board. But then surprisingly, my interviewer actually said that I could make a good intern for the next summer. I was applying for a full job. It didn't make a lot of sense. So the next summer, I ended up leaving Canada and going to the Bay Area to work at Apple as an intern. So during my internship, I ended up implementing the machine outlining pass at LLVM. The idea was that we could find these repeated sequences of instructions in a program and then pull them out into functions. This would hopefully save some code size. And then during this period of time, I also graduated from university. My initial plan was to go to grad school and do more algorithm stuff. Unfortunately, there was nobody to supervise me at UVic, and so I had to choose to go to school somewhere else or stay in industry. I was learning a ton working at Apple when I was an intern. So I decided that I would take a full-time position at Apple instead of going to grad school. This also gave me an opportunity to not panic about my student loan. At the time, I was a little insecure about this, and I thought I was somehow failing myself by not going to grad school. But today, I don't really regret that decision at all. I think I would have been happy at academia as well, but I've learned a ton about compilers and general software development in industry. Academia and industry are just different paths, and they're fulfilling in their own unique ways. After my internship, I gave a dev meeting talk on the outliner and eventually led it in open source. The code review process was a little intimidating at first. When you put something up in public for the first time and ask for criticism, it can be a little nerve-wracking. The best thing to do in this situation is to step back and ask yourself, well, what's the worst that could happen? And once again, the worst that could happen is that you temporarily embarrass yourself. And the best that could happen is you get your code into a massive open source project. You also have that benefit of learning a lot from your reviewer's input. So I think that both those things happened. I embarrassed myself a lot, and I also learned a lot. I think the trade-off's pretty good. And as time goes on, I think I embarrass myself a lot less, or maybe I just don't feel embarrassed as easily anymore. Today, almost 5 years later, I still work on the same team at Apple. As my career has progressed, I've touched more and more places throughout the compiler. I've worked on the new instruction selector, global iCell. I've mentored my own intern, and he landed an IR similarity framework in LLVM that builds on my machine outliner work. I've gained a lot of confidence in my ability to just dig around the LLVM source. And I even gave a WWDC talk, or the first 10 minutes of one, which included my outliner work, which was pretty cool. So if I went back in time and I said, hey, 14-year-old Jessica, you're going to work on a compiler, I would have said, what's a compiler? I want to draw anime. Now, what do I want you all to gain from this? Well, one, let's say you want to contribute to open source LLVM, and you've been putting it off because you're afraid. Well, what are you afraid of? Does that fear just reduce down to, I'm scared of being embarrassed? Well, just swallow that fear. The absolute worst thing that can happen is you have your ego bruised and you learn something new in the process. Two, let's say that you want to contribute to LLVM and you don't know where to start. Talk to people. There are lots of compiler engineers on Twitter. There's an LLVM Discord. They mostly make bad puns. They're all extremely friendly, and they'll help you find something to fiddle with. Even if they're a big name in compilers, all these people really care, really care about some aspect of the compiler, and they want to share it with you. And finally, number three, don't feel like you need some sort of specific personal history to begin exploring something new. I didn't know I was going to work on compilers. There's no way to know. Most people were surprised that I was going into computer science at all. I ended up where I am because I decided to try new things, keep doors open, and push past any fear that tells me that I can't do something. That's all I have, and thank you for listening to my talk.
Thank you, Jessica, for sharing some of your insight. Next up, we have Anastasia.
Hello, everyone, and nice to meet you. My name is Anastasia Stulova. I work at ARM on OpenCL compiler, and let me share my career story. First of all, I would like to start from kind of sharing with you why and how I ended up in computer science at all. It all happened in my final year in school when we had to take one practical subject, and it was quite common in Soviet and post-Soviet Russian education. I have no idea if it's still popular, but I did find it quite useful because the idea is that you learn how to apply your knowledge, first of all, and also how to utilize your interests and talents. And from the typical choices that girls would choose from the list of subjects, I actually didn't like anything, pretty much. There were lots of things like singing or drawing or cooking. And the only subject that I found somehow interesting, but I didn't have any experience with it, was programming. I didn't even have a computer at that time. So I have decided to be adventurous and explore something new. When I came to the class, I was a little bit intimidated because, of course, it was full of boys, but it was taught by a female teacher, and she was really interesting personality. She was very intelligent. She was a very charming person. She was also really great at teaching the subject. So I kind of really got into it, and at the end I became one of the top in my class. And I think that helped me to start breaking the stereotypes, the gender stereotypes in computer science. So at the end of my school, I decided that I want to pursue computer science career, and I applied to computer science faculty. So next, let me talk how my experience with compilers. I first took a compiler course during my undergraduate in Russia, and I actually didn't like it at all. And funny enough, it was covering front end and parsing technique, and right now it's kind of my day-to-day job. But at that time, I found it kind of too theoretical and boring in a way. So I really didn't see myself as a compiler engineer. I took more courses on compilers during my postgraduate degree in Switzerland, where I shift my subject slightly from software design to electronics and computer design as well. And the courses there were more comprehensive, so it covered different areas of compilers, so I could immediately see the connection between the different components and how they could be used together to create a useful tool. We also had practical exercises where we would work with commercial tools and also open source tools. And one thing that I think fascinated me at that time is that there is this interest in theory, and I really like the theory, and I could see that it's actually used in practice. And in some of my courses, one of the problems was that I couldn't really see the practical aspects or the connection to reality, and that kind of didn't make them interesting, so to say. So I decided that I would like to try a computer engineer, a compiler engineer kind of path. And my first job was a researcher at Aachen University in Germany, where I was working in the lab that was designing electronic design, automation, and also compiler tools. Interestingly, these two fields share a lot of theories and methodologies, but after some years, I realized that compilers were more interesting to me, maybe because my first degree was kind of software oriented. That's why I kind of decided I want to stay in software field. In that time, I also got acquaintance with the LLVM project, and I was only a downstream user. We used the LLVM to prototype various compiler tools for parallel programming and for heterogeneous hardware as well. So my next job, which is my current job, was OpenCL compiler engineer at ARM in the United Kingdom. And for me, it was kind of the dream job, so to say, because it combined, I could work on compilers full time. I can also work on LLVM project because I really liked it. And I could also use kind of knowledge in parallel programming because it was OpenCL, which is kind of very parallel. So it was really great. I started working on new standards, and I started from implementing and then also designing compiler stacks for the new OpenCL standards. Then I basically started working more with language and standard definition and the front-end design, and therefore I was engaging more and more with LLVM community and also with Kronos group that standardizes the OpenCL. And 2 years after I started my job, I became co-owner of OpenCL in LLVM project in Klang. And 2 years after, I also created a technical subgroup in Kronos that looks at the tooling aspect for the next OpenCL standards. In 2019, I co-authored C++ for OpenCL programming language, which the idea is to bring kind of C++ features in traditional OpenCL programming, which was C99 based. And we also developed with my team a compiler supported for it that was released in Klang 9. Maybe just in kind of next few minutes, I would like to cover my open source engagement, in particular with LLVM project, and maybe to kind of tell why I actually enjoy working with LLVM community and LLVM project. Well, first of all, I don't actually think that open source projects require different set of skills, especially when it comes to technical side. So it's pretty much similar to our compiler projects. But one of the things that is quite different is the community aspect. And that means that you kind of need slightly different mindset and maybe kind of shift in working culture. And for me personally, I found it great. And one of the things I enjoy is that if you participate in community life, you can actually shape it. Let's say if you don't like certain process, you can work with community to improve it. If you don't like certain things, or if you like certain things, you can make them even better or use them even more. And that's really great. It's not very easy to get in regular projects. This is one thing. And then, of course, it has social aspects. And also the fact that you work with very diverse community, with people from everywhere in the world, people with different backgrounds in different countries, and they all have their own kind of strengths and set of skills, and you can learn so much due to that. Something personally for me, I really like to stay in touch and kind of actively engage in the community life, even though I don't think it's necessarily kind of like it's very necessary, but I personally think that in many tasks, you could be more effective if you do engage with the community. And in particular for me, I try to stay in touch via mailing lists, for example, discussing certain new features, or maybe asking certain questions, or answering somebody's question if I have knowledge about something. That's really great, an easy way to stay in touch with the community. I also attended many developer meetings as a normal attendee and as a speaker as well. In 2019, me and my colleague created Clang tutorial to help newcomers start hacking Clang. And the idea is that we were both newcomers some years ago, and we didn't have anyone mentoring us, so we had to learn Clang by actually doing our work and by interacting with community. So we thought we would cover all this important information that helped us to build up knowledge and show it, kind of create a tutorial using this information. Yeah, so I think that maybe something to point out as well, that I personally find that in particular LLVM project, but also many other open source projects, because they kind of combine people with so many different backgrounds, a very really great working environment for people with diverse backgrounds, and really help to kind of integrate people with different backgrounds. Great, that's all from me, and thank you for listening.
Thank you for sharing your path and your career. Next up, we have Teresa.
Hi, I have a few slides that I'm going to share. So let me pop that up here. Okay. So my name is Teresa Johnson. I am currently a senior staff software engineer at Google. And I just want to talk a little bit about how I ended up working in compilers. Just mention a couple of things I've worked on, but then spend some time talking about some things that I've learned throughout my career that hopefully are useful to people who are earlier on in their career. So at a high level, my degrees are actually in electrical engineering. After I got my PhD, though, I started working in compiler optimization, and I'll talk more about how I got there. But I worked at HP for 13 years on our proprietary compiler. Been at Google almost 10 years now, working on optimization. And I actively develop in LLVM. I'm also an individual contributor, which means I'm not a manager, and that's by personal preference. So originally, actually, I planned to do pre-med, and thankfully, by the time I was applying for college, I realized that might not be for me. My dad had a background in physics and nuclear engineering, and so I thought maybe engineering might be a good fit. I liked science. I picked electrical kind of, I don't really know why. I think it seemed fairly broad, and so I picked it. And luckily, I did like it, but it wasn't until I think the beginning of my senior year of undergrad that I took my first computer architecture class, and that's when I really found my passion. I'm sort of very analytically, logically minded, and so that fit my strengths, I think, more than any other area of electrical engineering. I had actually decided pretty early on that I was going to go to graduate school. I think I had this romanticized idea that doing research was really cool. But once I found my passion, I then knew that I was going to go to graduate school and study computer architecture. And in fact, my advisor, Wenmei Hu, was the one who taught that first computer architecture class. So our research group, it focused on a type of architecture called VLIW, very long instruction word. These are statically scheduled architectures in order executions. So essentially what that means is that the compiler is really critical to making this perform well. So even though my research stayed on the computer architecture side officially, I ended up contributing to our research compiler. And I actually don't think I ever took like an advanced compiler course, but I learned compilers by reading papers and just hands-on work. So when I finished my PhD, I actually looked at both microarchitecture jobs and compiler jobs. And this is when Itanium, this is a VLIW architecture. I think it was about to be taped out, the first implementation. And so I felt that actually the compiler side work would be really interesting. And the other thing too is that at HP, which was where the compiler job was, I really liked the environment. So I knew people who worked there already who had been in grad school with me, and they, talked about how it was a good research and, combination of research and development. And, they talked also about how the environment was flexible, which was important to me. I was planning on having kids in a couple of years. I wanted to have a more flexible schedule. And I also saw a number of women who had good technical, jobs, positions there. So I stayed there for a while, got promoted for a couple times, but then decided it was time to move on. And I had some colleagues who had already moved to Google, and I knew that they were doing compiler optimization work. And so I ended up moving over there. And so at Google was actually the first time I ever worked in open source. Before that, it was a proprietary compiler. Before that was a research compiler. And so we initially were working on GCC, and about 5 years ago, we moved to LLVM. So just a smattering of things I've worked on. So Itanium, like I mentioned, statically scheduled. So I worked a lot on data cache latencies, handling them, instruction scheduling. Those are really critical things. And also because we were a hardware vendor, we looked a lot at optimizing for benchmarks, spec benchmarks, TPCC. And then when I switched to Google, it was kind of a big change in focus because there we were compiling for x86, so out of order execution. And suddenly the things I had been focused on for so many years were not really as important. And also looking at real world applications is very different than compiling, optimizing benchmarks. So for Google, we have these really large server applications. You suddenly have to start worrying about the size of your code, the instruction cache, and also the scalability of the optimizations that you're developing. And so actually one of the key things that I've worked on in recent years is a framework called ThinLTO. This is developed in LLVM. It's a framework for scalable whole program optimization. And it came out of the needs of what we, for the codes that we are compiling. And after a lot of work, it's now default for our production builds. Okay, so switching gears a little bit, some things that I've learned during my career. One, and this is kind of relates to some of the things I mentioned on my prior slide, uncomfortable changes are a little scary, but they can actually lead to really good opportunities. So when I switched over to Google, suddenly all the things that I felt like I was a domain expert on were not as important, and I worried about making impact. And as it turned out, really what I've developed a lot over my career is problem solving abilities. And so just bringing those to a new problem actually can be a good opportunity. When we transitioned to LLVM, it ended up, that was a big change, but it enabled us to design something new from the ground up. So that was another big change with a big opportunity. And the other thing that I've discovered is how beneficial it is to work in open source. So when I first started working in open source, it seemed like a lot of overhead. Instead of getting my changes approved by my colleague, 2 desks down, I now have to get buy-in from a much broader community of people. But in the end, even though maybe there's a little bit longer time to make big changes, I think, end up benefiting a lot from that big variety of input that you get. And then on a more personal note, it leads to actually much higher visibility work. So you're interacting a lot more with people outside your company. Because you're working in open source, you can talk about what you're doing. So we were able to, for the LTO, we could publish it. I was able to give talks at the dev meetings. And then I started getting invited to give a number of other external talks. So for me personally, this led to much higher visibility than working on a proprietary compiler where I couldn't necessarily talk about what I was doing. The other thing I wanted to share is that as I've gone through my career, I've had this kind of evolving perspective of how large the domain is and how much I know and how much I will ever realistically ever know. And I wanted to show this because I want to point out that no matter what your education is, how many degrees you have, how many years of experience, most people have some kind of imposter syndrome. And for me, dealing with that it's helped to realize that I think a lot of people have very sort of slightly overlapping areas of knowledge. And so if you think of that way, you can use it as an advantage to actually do more impactful work, not being afraid to ask questions, and also collaborating with people who have complementary skills and sets of knowledge. And the other thing I want to point out, because I talk about having gotten a PhD, I do want to explicitly say that you really don't need a PhD to do interesting compiler work. Obviously it's going to take time to grow your domain experience. And also for me, getting a PhD, I think one of the biggest benefits was building my critical thinking skills and being able to do really deep analysis. And you don't need to be in an academic setting to do that. That's just where I developed those. I also wanted to share that career progression, for me, maybe it looks linear. I got promoted sometimes, moved to Google, got promoted. But here's the reality. I mean, my schedule and how I work has been all over the place, especially as I had kids. I've been part-time, I work a non-traditional schedule. And I wanted to share that because I want to point out that it's possible to grow your career while you balance your life with family. And I did manage to get promoted while working part-time. And I think for me, what happened is as I dropped my hours, it forced me by necessity to prioritize very carefully and also just to be much more efficient. And of course, your mileage may vary, but I think that compiler work actually lends itself quite well to more flexibility. So I don't know where I am in time, but my last slide, and I'm not going to go through all of this, but I just wanted to highlight a couple things. So, and I think you've heard this in the other talks, being a successful engineer there's not one mold for this. So I've frequently been the only woman in the room. And perhaps I've been lucky, but I've actually had a really positive experience. And I think it helps. The LLVM community in particular is very welcoming. And so I think in this domain, actually, it has been very positive for me as a woman, even when I'm, one of only a small set of people that looks like that. And also, my background as a kid, I never was tinkering with robots. I'd never, built my own computer from parts. I mean, I don't have hobbies that kind of look like what maybe a typical engineer should have. But what I love about my job is solving mysteries and puzzles. And that fits really well with what I did as a kid and what I enjoy doing. And so I wanted to point this out that, many different skill sets and many different types of interests can actually lend itself really well to being a successful engineer. And I think I'm out of time, so I'm going to pass it back to Cindy. Thanks.
I firstly like to say thank you to all of our speakers for sharing the different aspects of their career with all of us. And so I'm opening this up to Q&A. If we could bring back all of our speakers for this lightning session. All right, awesome, great. And then so I will start with the first question, and it can be open to anyone, any of our speakers. So I've discovered my love for compiler development when I was in Swift as a GSOC intern. However, since I live in Egypt, there's absolutely no compiler development jobs here. TLDR, do you have any recommendations on what to do until I can get a job opportunity abroad? Does it make sense to do compiler development in my free time?
I mean, I think it makes sense to do compiler development in your free time. You already have some experience working on Swift. I'm sure that there's, at this point, plenty of things that you've kind of seen that you feel confident enough that you can change them and maybe make a difference. If you are very interested in this topic, why not just spend some time working on it? It's not going to hurt you. That's basically all I can say with that.
I actually think that working kind of on compilers on free time can help you to build the knowledge you actually want to build. In a way, I actually want to have a free time to do some more work in compiler, not necessarily in the area of work, because it has so many different areas and so many aspects. So yeah, it's great. And by the way, for newcomers, I think we used to have the new starter box. I'm not sure if it's still like kind of alive, but if not, just feel free to send email to a mailing list, and I'm sure that people will find a lot of interesting topics.
Thank you. Another question is there any advice for self-taught engineers? I was here, and I don't come from a CS background, but I want to get into compiler engineer. Should I go back and take an undergrad compiler class, books to read, another path?
I have to say, there are so many online tutorials these days, like on Coursera and other platform. I guess it's up to you, like how you. I think some people really like to learn from the class and kind of having a tutor and the people around. But I think there are so many things online you can learn these days. But,
yeah, I was just gonna follow up a similar response and say, you don't have to take an undergrad course or a traditional like learning method. I think that you could definitely, find online resources, but also I would say kind of get involved with the community. So someone mentioned also starter bugs as well. So if you're interested in Swift and contributing to Swift, look at some starter bugs or even documentation changes and just start getting involved in the forums, talking to people. I think that's the best way, is really getting involved in the community and kind of building up your skills gradually, because a lot of times if opportunities do come around for more early career positions and whatnot, if you're already involved in talking to people, it's a bit sometimes easier to find out about those things.
Thank you. Another question is, do or did you have mentors? What have you learned from them, and how did you find them?
well, as I mentioned in my talk, for the LLVM and Clunk part, we actually didn't have any mentor in my team. We kind of wanted to do something, but nobody was experienced or like kind of new. We had one person, but he left just before I got hired. So it was quite challenging. But I must say, I think if you work with open source projects, you can find so much information everywhere. Sometimes it's confusing because, okay, it's a lot of information. Something might be outdated, but there is always community to talk to. Yeah, so I think it depends. I think it's great to have a mentor, but if you don't have one, it's not a problem.
Yeah, I never had a formal mentor. I think I've been in my career for a while, and there was, when I started, I was kind of before there was all these formal mentorship programs, which I think are great, but they weren't really there. But I had what I would say is sort of informal mentors, just people that I looked up to, who I ended up, just spending a lot of time talking to and learning from. So it doesn't even have to be like a single mentor. You can have various people that you play part of a mentor role that you just learn from. And so, even if you don't have access to a formal mentorship program, I would just, encourage you to like make those connections, and you can, find a few people that you feel comfortable talking to and learning from.
Great, thank you. And then so another question, imposter syndrome is quite ubiquitous and compilers are traditionally hard topic. What can we collectively do to lower the barrier of entry? This is kind of a loaded question.
Calling it hard. Like, that's the first thing. Like, when you tell somebody that something is hard, half the people in the room, they're going to behave differently because they know it's hard and they get something in their head that says, I can't do it. There are some weird people like me that, I hear, oh, this is hard as a challenge, but that's not the vast majority of people. I feel like maybe introducing these concepts like, basic compiler concepts earlier in a degree program, making them more accessible to people just by like, instead of having a bunch of jargon, say, surrounding a bunch of different concepts, what if we just said, okay, we have some source code. What can we do to it to say optimize it? Or what are the steps that we might take to get to, say, a final linked executable? Making these things not sound scary in a way that, say a first year CS student or a person who's just interested in programming and they're picking up a book or reading a tutorial online, they can follow it along and get the big picture idea. I think that when they come up to the to the actual formal compiler stuff eventually, it won't be as scary or I don't know, like intimidating at that point. But I think the main thing is to just stop saying it's hard and stop kind of glorifying this sort of like you have to be elite hacker or whatever to work on compilers kind of attitude that seems to be surrounding the field.
Yeah, and I would like to add to that. I think sometimes it's also about just not being afraid to kind of show that you don't know something. For example, for me, it definitely worked. After a while, I started to understand that people that learned more and kind of learned faster were those that were asking. Sometimes you think it's a silly thing, but actually, it's not a problem to ask and not a problem kind of to share what you don't know and what you would like to know.
Thank you. So I have a question for Teresa. When you chose to work part-time to balance your personal and work life, did you feel left out of your work? How did you overcome this?
Yeah, so thanks, Jibby, for asking that. So one of the things I didn't have time to mention is that when I went part-time at HP, I didn't know anybody else who worked part-time. There was not like a part-time program or what, it was not a formal thing. I actually tried like working from home one day a week when I had a kid, and then I felt like I was ignoring my kid and my work. So I said, okay, I just asked, and I was surprised, they said yes. And then eventually I had a second kid and I said, can I drop to 50%? And then they said yes. And I'm like, great. I think sometimes it's asking for what you want, even if, it may not be possible. The worst you can get is no. So I wanted to just mention that. But in terms of being left out, not really, actually. I mean, I have to say though, even when I wasn't in the office, I did try to make an attempt to like answer critical emails. I mean, the problem with working part-time is you're not ever completely just those hours, but I think that's true even when you're full-time, like you go home at the end of it, and sometimes there's critical things that come in. So just making sure to like, just make sure that I responded to sort of critical things. But I think that what happened is my interactions, I just scheduled them for the times when I was going to be in the office. And I've been lucky that I worked in groups where people were supportive of this. And so they didn't, schedule meetings outside of my normal hours. So, it's obviously a little bit harder, but it wasn't terribly difficult to stay connected. Yeah.
Thank you. And then I have a question. So much of the tech space is saturated with a specific demographic. Have any of you ever been fearful to present your work to an audience that's primarily made up of folks who don't look as much like you? And how have you overcome this fear?
Yeah, I can talk to that. My first ever like really technical talk at a kind of very well-respected mobile development conference. This was probably like maybe 4 years ago, or like, yeah, maybe four or so years ago. And I was like terrified. The audience was like very male, very like skewed older, very white. And I just thought like me going up there that they like, I don't know. I just thought that it wouldn't matter really what I had to say. It wasn't interesting, or they would find some flaws in my talk and pick me apart in the Q&A. I was terrified, but honestly, it just wasn't like that at all. Like, it was great. I gave the talk, and like afterwards, folks were like, thank you, I learned so much, and asking me questions. And that is really kind of what encouraged me to continue conference speaking and staying involved in the community, because folks were really just really open. And I think that's the thing that, when you're when your identity is maybe not as common in your workplace or in the community, the technical community that you're a part of, not necessarily letting that stop you from realizing that you have expertise and knowledge to share with the community too. Because I think sometimes like we feel like, oh no, well, what do I have to say that's unique on this topic? But everybody has a unique perspective on how to solve problems, right? And so when you share your perspective, you'd be surprised like how many people can actually learn from you and really take from that. And so that's really why I've loved kind of just being engaged in the community, because I realized that I have things to share with the community. I can learn from the community. They can learn from me. And so don't let that fear, that initial fear kind of stop you from being involved.
Thank you very much. So I think we're all through with the rest of our questions. We are going to leave this Remo session open for networking, so I welcome if you can. And then thank you again to all of our speakers. We really appreciated you sharing some of your anecdotes and your career path. It's been very insightful. And yeah, thank you very much.